Hey guys, welcome to Conceptual Geometry, lesson 4.7, rotations. So what is a rotation? You can think of a rotation as spokes in a wheel. And you attach something to a spoke, and then you spin the wheel. What happens to that object? The symbol for rotation is a capital R, or you might see ROT. But usually, unfortunately, it's capital R, and a lowercase r means reflection. A rotation is positive when the rotation goes in a counter-clockwise direction. So that means this direction, that's positive. A rotation is negative when it goes in a clockwise direction. So if it goes this way, that's actually a negative rotation. Okay, so let's jump right into an example here. It says rotate triangle BCD 90 degrees about the origin. Label it B prime, C prime, D prime. So what we're doing is we're taking this triangle and we're rotating it 90 degrees. So think of it as being on a spoke. I'm going to rotate that spoke 90 degrees. So what's that triangle going to look like? Well, here's what I like to do, and it's a little bit challenging, but I'm going to start with point B. And if you rotate these axes 90 degrees, point B rotates to here. And that would be B prime. Point D would rotate up to here, because that would be 90 degrees. So that's going to be D prime. Point C would rotate to here. So that would be C prime. And one way you can kind of figure this out, if you take a look, here's your origin. I went over 4, up 3. And I have to rotate that 90 degrees. So that'd be like going up 4, over 3. All right, hopefully that kind of helps. It's much easier if you're in class, unfortunately, for this. I can do this on a smartboard pretty easily. So there's that triangle. Again, that's what it would look like if I took this spoke and I rotated it 90 degrees, like so. All right, now I want to rotate our new triangle. Oops, sorry, right here. Rotate our new triangle 90 degrees about the origin. And I'll label this B double prime, C double prime, D double prime. So now this has to rotate down here. So again, there's a couple ways you can do it. You can take a look at point B. If you have to rotate it 90 degrees, it's going to go here. Right? Think of it this way. I had to go up 3 over 2. If I rotate that 90, that's like over 3, down 2. That's how I would get that. B double prime. Same thing with D. I went up 5 over 1. I have to rotate that 90 degrees, so it's like over 5, down 1. So that'd be D double prime. And then with C, up 4 over 3 is like over 4, down 3 if we rotate that 90 degrees. C double prime is there. And then sketching that triangle. Now notice, for each one of these rotations, the triangle doesn't change size or shape. It's the same size, same shape as in the previous examples. Okay, so I think we're on C. It says a rotation of 90 of triangle B prime, C prime, D prime. So this rotation here, going from that triangle to this one, is the same or equal to what rotation of the original? So going 90 degrees from here to here is equal to what rotation of this one to here? I think you guys can probably figure this out, right? Rotating to there is 90. And I take that one, rotate again 90. So together, that's going to be 180 degrees in one shot all the way around. Okay, so it'd be 180. And next, I have to take my latest triangle, B double prime, C double prime, D double prime, and rotate that 90 degrees about the origin. So this one is going to rotate over here, 90 degrees. So again, what I think I'm going to do is kind of visualize, okay, over 3, down 2, rotate that 90 is down 3 over 2. So B double prime is going to go right here. D double prime, or D triple prime, I should say, over 5 down 1, rotate at 90 is down 5 over 1. So that'd be D triple prime, add triple prime there. And then C over 4 down 3 becomes down 4 over 3. So it goes right there. C triple prime. So now before we answer all these questions, I just want you to take a look here and kind of understand what we've done. This triangle to this triangle was a rotation of positive 90. This triangle to this one was a rotation of positive 90. This triangle to this one is a rotation of positive 90. I can go one more, here to here is positive 90. Well, 90 plus 90 plus 90 plus 90 is 360 degrees. So if I go all the way around back to the original, that's 360 degrees. Here to here is 90. Here to here is 180. That's 90 plus 90. Here to here is 270, which is 90 plus 90 plus 90. So you're going to see these numbers often, 90, 180, 270. Now let's go back up and look at these. If we take B double prime, C double prime, and I rotate that 90, that's equal to what rotation of triangle BCD? We just sort of said it. That's going to be 270. Okay, so I can fill that in. It says if I take this triangle here, the triple prime triangle, and rotate it 90 about the origin, what is the name of the image? So if I take this one and rotate it 90, what's the image? What's my original one? That would be triangle BCD. What if I take the original triangle and rotate it negative 90? So negative means I go the other direction. Where does that go? Well, it goes to this one. That's the triple prime one. Triangle B triple prime, C triple prime, D triple prime. What if I take the original one and rotate it negative 180? So take my original one, rotate it negative 180. I think you guys can see that negative 180 is actually the same as a positive 180. So I end up with this triangle right here. That'd be triangle B double prime, C double prime, D double prime. Oops, sorry about that. Double prime. So now I'm going to take triangle BCD, which is my original one, rotate negative 270. So here we go. Negative 90, negative 180, negative 270. That ends up being this one right here, which is the single prime. Triangle B prime, C prime, D prime. All right, let's try another one. I know that's a little bit confusing, but again, we're going to kind of spend a few days on this, so hopefully it kind of sinks in. Findings from the previous page. A rotation of the original triangle of 90 degrees equals what rotation of BCD? Well, a positive 90 we said was equivalent to a negative 270. And we said a 180 is the same as what? Well, we said that was the same as negative 180. We also said a 270, so if I go positive 270, that's the same as a negative 90. And this last one's a little confusing. Notice that is a rotation of 180 is equivalent to a reflection in what? So if we start here and we rotate 180, what's that the same as? It's a reflection through the origin. So what might a rotation of negative 50 degrees be equal to? Well, I kind of like to think of it as a circle. So if I start here and I rotate negative 50, that's clockwise 50 degrees. So that part of the rotation is 50 degrees. What would that be equivalent to? What would I have to do going the other direction? Well, if this negative, that's a negative 50, first of all, so this red rotation would be positive, and together, I know that these two must add up to 360 degrees. So this is kind of easy. If that's a negative rotation, then the other one's got to be positive. And to get the angle, I just have to take 360 and subtract that 50. So that's going to be 310. So this rotation is equivalent to a rotation of positive 310 degrees. Okay, in each of these, what rotation is equivalent to the given rotation? Well, if I start with a negative rotation, I know my answer's got to be positive, and I just need to take 360 and subtract that angle. So in this case, it's going to be 295. So visually, here's what we're saying. I rotate negative 65. That's the same as going all the way around the other way, a positive 295. And the positive and negative just tells you what direction you're going. So how about this one, a rotation of 200? Okay, well, I know the other one's got to be negative, and I just take 360 minus 200, and that gives me 160. So a rotation of 200 is the same as a rotation of a negative 160 degrees. Rotation of negative 145 is the same as a rotation of a positive, and I take 360 minus 145. What's that going to give me? 215. So that's going to be 215 degrees. And a rotation of 170 would be equivalent to a rotation of a negative, and I take 360 minus 170. All right, so that's going to be 190. It's the same as a rotation of a negative 190 degrees. Okay, let's take a look here, our last example for day 7. I'm starting with this shape, A, B, C. Looks like a backwards check mark, but they've got our coordinates here. And the first thing they want us to do is rotate it 90. All right, well, if I'm going to take that and rotate it 90, it's going to end up going over here. So I want to be visual first. So I go over 3, up 2, and I rotate it 90, it'd be like up 3 over 2. So that would go right here. That would be A prime. What are its coordinates? Negative 2, 3. What's going to happen to B? Well, I go over 4. I got to rotate that 90, so it'd be like going up 4. It's going to go right there. So B prime is going to be 0, 4. And what happens to C? C is over 5, up 1. I rotate that. It's like up 5 over 1. It's going to go right there. And I connect A to B to C. So there's that. And C has the coordinates negative 1, 5. So like we did with reflections, we're going to look for patterns. 4, 0 became 0, 4. 5, 1 became negative 1, 5. All right, so now what I want to do is I want to take this and rotate it 180. So it's going to go all the way around here, which is basically the same thing as taking this one and just rotating it 90. So I'm going to rewrite my coordinates. All right, use a different color. So A prime we said was negative 2, 3. B prime was 0, 4. C prime is negative 1, 5. Now I'm going to actually use a pattern to get the coordinates before I'm visual. So how can I get these without using that? Well, take a look here. 3, 2 became negative 2, 3. So 3, 2, 2, 3. I changed the order, and I negated the first one. So if I take these and I change the order and then negate the first one, this is going to be A double prime, negative 3, negative 2. Well, let me plot that and see if it makes sense. Negative 3, negative 2, there's A double prime. Yeah, that makes sense. Up 3 over 2, I rotate that 90, is over 3 down 2. Yeah, that worked. So let's kind of follow that pattern. Switch and negate the first one. So B double prime is negative 4, 0. Well, negative 4, 0, there's B double prime. And same thing here, C double prime, switch and negate the first one is negative 5, negative 1. There's C double prime, A, B, C. Yeah, that makes sense. Look, I'm rotating 90 each time. And then you kind of see the pattern here. Let's copy these coordinates, the double primes. That's negative 3, negative 2. That's negative 4, 0. That's negative 5, negative 1. So again, what I want to do is I want to come up with these first using the pattern. Switch and negate the first one. So A triple prime, if I switch and negate the first one, becomes 2, negative 3. Yeah, that makes sense. There's A triple prime. Switch and negate the first one. So B triple prime is 0, negative 4. Remember, when you negate a 0, it just stays 0. So 0, negative 4 is B triple prime. And switch and negate the first one, C triple prime becomes 1, negative 5. 1, negative 5 is there. And A, B, C, yeah, same shape. And then the last one's a little redundant. It says, okay, well, what if I take the original one and rotate it 360? So rotating 360 is the same as original. I'm really not going to go over this. You could just copy these coordinates down over here if you wanted to. But we don't really rotate anything 360 degrees because what is the point? But basically what we want to do is we want to get used to rotating 90, 180, and 270. Okay? All right, so that's kind of an introduction. You should be able to do the homework worksheet 4.7 after this introduction on rotations. And as usual, guys, if you have any questions, don't hesitate to reach out. Thanks for watching.